The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Ben, why are you so happy?
Because, Felix, we have a table filled with oscilloscopes.
What are oscilloscopes and why are they here?
Well, Felix, oscilloscopes are devices that allow you to look at very small changes in frequency and amplitude of electrical signals. You know how you can blink an LED to see if something is working?
Yes.
Well, what if you're doing something that's at very high speed, like pretty much any protocol? You can't see the LED blinking anymore with our primitive eyes, but you can see those small changes with an oscilloscope. It's like a microscope for electronics.
That sounds really great. I am really looking forward to seeing these work.
Yeah, so what happened was we decided to do an episode talking about oscilloscopes. I mean, we often have them in the background of episodes where we're using them off camera or we demonstrate one thing on an oscilloscope, but we're gonna go into more detail. Now we have 5 different scopes here from Tektronix, Rohde & Schwarz, and Keysight. All 3 companies were kind enough to send us some of their newest scopes to evaluate. We're gonna talk about the differences between the scopes, what they can do, and then put them all through some demonstrations.
Let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, the first scope we're going to talk about is the Keysight DSOX1102G. So this is a smaller scope. It's slower, it's only 70 megahertz. But the idea here is that Keysight wants to have a more affordable range of scopes. Typically, if you're looking at like the $300 to $500 range for scopes, typically you'd be looking at like a Rigel scope. But yeah, I think Keysight wants to get into that price point, and this is their entry.
Yeah, this is a very nice entry-level scope.
Yeah, it's only 2 channels, but it's kind of small. It's easy to use. It's not, inundated with controls, so it's a little less intimidating when you go to use it. So what we're going to do is just talk about some of the base features of the scope, how it differs from the other scopes, and then use it in an example project. The thing that we're going to do is going to try to reverse engineer the data signals going to the LCD screen of a portable DVD player. Well, it looks like we just happen to have a random DVD player laying around.
How about that?
Obviously, DVDs are completely out of date now. Let's see if it still turns on. Yeah, there we go.
It's alive.
I'm going to count the pins. I mean, if there's only like 8 pins, then we would know it's differential signaling.
Okay.
But there's more than that. 22, 23, 24. 24.
Is that a common number of pins for a screen?
Yeah, the 4 on the end look like they're power and ground. So that would...
The left side there?
On the right side. See, it's got the capacitor there.
All right.
So we need a tested ground point. Felix, can you find a common ground on here? This is probably one right here. And maybe let's solder 2 little leads to it so we can attach the clips of the scope. All right, so we're going to hook up our ground probe for reference, and then we're going to see what we can see over here.
Hey, check out this awesome feature.
What?
There's little feet.
Oh, I didn't know it had that. Cute. All right, tell me if there's any signals that appear on the scope, because I got my face in this.
There's something.
Hit run stop. Run stop pauses the scope's acquisition and allows you to take a look. Hey, is there anything in here that stands out to you, Felix? Any numbers? You want a hint?
Yeah, I do.
The frequency,
okay.
15.8 kilohertz. That's a really common horizontal sync frequency, like how wide the screen is.
That's good, because I didn't know that.
Yeah, the 2 leftmost pins, I can't actually see anything attached to them, so they actually might be ground. Actually, let's check that before we continue. Meter, please. Yep. 2 grounds. Okay, let's go back in. Can you plug it back in for me, please?
Yes.
Okay, pin 3, you ready? Yeah, hit run stop again. Oh, what the? That's interesting.
So there's like some kind of information in there?
Well, it looks like, that looks like a NTSC signal.
I'm glad you recognize that.
Oh, you know what? Does this thing have a composite output jack on it? AV out, it does. That's what that is. That's not horizontal sync, that's composite output.
Okay.
What's it doing there? The way you can tell is you have these valleys here, right? So what they do is they have 0 volts as the sync reference, and then you have a slightly higher pulse when you start, and then you have your information here, right? it's a little hard to see on the scope. If we hook that signal up to a screen, we would get some sort of information. Okay, so that looks like composite.
Cool.
Which I didn't expect to see on this. Okay, going for pin 4.
It's something.
Hit run stop. You know what this kind of looks like. Hey, there's a way we can test. If we put that and the other signal on the scope at the same time, we can learn more by looking at the relationship between the signals.
Okay.
So I'm going to move this one up here a little bit. I'm going to move channel 2 up here. So these controls, this basically changes where the waveform is on the screen. And right now they're both baseline to 0 volts. You can reset it by tapping or pushing the button in. Most scopes work that way. So let's put this one up a little bit and this one down, and then we can see them both. We want to make sure they're both the same division. Let's go 2 volts per division. So I'm going to hit pin 3 on probe 1 and then 4 on, okay, let's see if I can get these. Got 1. Once we get both, hit run stop, okay? Now. Okay, so this is pin 3 and pin 4. Yeah, remember before when I said that there was something missing there? Mm-hmm. Well, there it is right there. So this isn't a composite signal. Rather, it's S-video.
Okay.
S-video is luminance and chrominance separated. So in channel 1, we can see the chrominance or the brightness. And then channel 2, we see the color information. Now in a composite signal or NTSC, you know, it's like yellow composite cables. This color burst information is mixed in with the luminance here.
Okay.
Because our NTSC color signal was meant to be backwards compatible with black and white televisions back when they created it in 1953.
That was a great discovery.
Which kind of begs the question, where's all the digital data? Well, Felix, we've come across some strange signals on this LCD that I wasn't really expecting, but it could also have something to do with the speed of this oscilloscope.
Right.
So I think we should probably try these tests with the next oscilloscope, next higher speed grade that we have to work with. Yeah, but just to recap, this little scope here, I actually really like it. I mean, it's not super fast, but I like how it's nice and small. It boots fairly quickly, and it's just a nice little convenient scope that you can place around anywhere you want. And it's also fairly reasonably priced.
Yeah, I think this is a pretty good scope myself.
Pros, it's small, it fits anywhere, it's cheaper than the other scopes that we're evaluating today.
We're limited by 2 channels.
Yeah, but a lot of times, you know, you're either using like 8 channels or just 1. So 2 channels, you know, it's like the bare minimum. Because like in this case, we're looking at the reference between the 2 channels. Because if you don't at least have 2 channels, then you can't see what the relationship are between signals, which is like half the battle, like when we're looking at the V-Sync and H-Sync. Yeah, but all in all, I like this little scope. I mean, this is a handy little scope to just, you know, have around. It's not super fast, but, you know, unless you're doing really high speed stuff, it's not a big deal.
I think it's nice and cuddly.
Yeah. So put like a little fuzziness around it, you know, like a teddy bear. Named after Teddy Roosevelt. Okay, the next scope we're going to look at is the Rohde & Schwarz RTB2004. Now, I believe Rohde & Schwarz is a fairly new player to the oscilloscope market.
Yeah, it's new to me. I haven't seen one before.
Yeah, me neither. So we're going to take a look at this. It's a 4-channel scope. It has the universal knobs, which we notice is pretty popular now, where they just have one set of knobs and you change the channel and then their knobs are color-coded to tell you what channel you're adjusting. This one does have a touch screen. That seems to be a pretty common feature in most, you know, higher range scopes. Yeah, so maybe we could use this and take a look at those same signals from the previous project and see if they look any different on this higher speed scope, because we're talking like, what, 4x faster? One thing I really like about this one, I want to just talk about it right now, is it boots really fast. It's the fastest booting scope of the ones that we are evaluating. It boots even faster than the little Keysight.
Let's do it.
I mean, it boots so fast we can show it in real time without any edits. We just have to talk about other things in the meantime. Like, oh yeah, I had like this grease on. Oh, look, it loaded already. That's pretty awesome.
Oh, when I was looking at this, one thing I found out is that the firmware is RTOS, which is a real-time operating system, and it's open source. I thought that was pretty cool.
Oh, so it's probably some sort of microcontroller or large FPGA?
Yeah.
Because the really big Tektronix that we're talking about later, that has a full-fledged computer inside of it. Cool. Well, let's swing this around, take a look, and yeah, maybe we can try to look at some of those signals from that previous project. Oh look, we can look at a video bus. We saw that earlier, remember? What was it on pin 3 of this? Yeah, here, why don't you try triggering it? Set up the trigger to the video bus.
What probe do you have? 1?
Oh, change the standard to NTSC. There we go. You have that trigger on C1?
Yeah.
All right, zoom out.
That's cool.
Keep going. Yeah, see how much cleaner this looks on this scope because of the speed? Go ahead and pause it. Stop. Yeah, let's change the scale. Channel 1. Yeah, you can see the whole thing. This over here, that's your active image area. There's a start of each horizontal line. See how it goes down to 0 volts, then it has a baseline value, then it has a luminance value right there. And I'm touching the screen, and it's some of the other scopes that didn't rely on the screen so much, you could disable the touch screen, right?
Yeah.
See right here, you can see part of the image a few lines down. That's probably the square that says open. And then these other colors, that's the gradient. See how it gets brighter to the right than to the left? So yeah, you can see the whole thing. You can see the start of the frame, all of the lines, and then the end of the frame. And then you can see right there, that's that open icon. The rest of it is a bunch of shades of blue. So yeah, I mean, this does have triggers to trigger on video where it finds not just a low pulse because the video is an analog signal, but it looks for the specific stair stepping that indicates that it's the edge of an NTSC line and it can sync to it. So it doesn't have a ton of bus analysis, but it's got some basic stuff.
All right, yeah, closing thoughts on the Rode & Schwartz. I really like, the screen is pretty big.
Yeah, nice and clear. It's really light. It's actually
Screen's
weighs
big.
less than the little scope.
It's light, boots fast. I think it's pretty nice.
I would say a negative is that it relies on the touchscreen too much. I'm not too crazy about these color changes here. I don't like the universal knobs. I know it's kind of a, the new thing. You like more screen, less knobs, but it's not as fast. It's not like, boom, there's knob 1, boom, there's knob 2. I believe this is, these are kind of a new thing from Rode & Schwartz. So it's pretty cool. It's got some neat features. Hopefully we'll see more revisions from Rode & Schwartz in the future.
Next oscilloscope on our list of oscilloscopes to examine is the Keysight Msox3004T. It's a 5 gigasamples per second and 500 megahertz.
Okay, so it's a little faster than the Rode & Schwartz we just examined.
With the oscilloscope that we had this awesome test board. This is demo board that has all these signals that it's spitting out.
Generates all sorts of signals.
And one of the signals is SPI. How about we analyze it with this awesome Infinivision Msox3004T Keysight oscilloscope.
All right, so let's see what we got here. All right, SPI bus, mode, yep, SPI. Oh yeah, we've got several things here. Oh, military standard, 1553. If we wanted to hook this up to like a F-14 or something, and say, I'm gonna figure out how much speed you need, Maverick. All right, so let's do SPI. All right, signals, okay, clock. Let's do clock on channel 1. Okay, so that's the clock signal. So yeah, it's in bursts of 8, that makes sense.
Freaking cool.
So we could trigger just on that. Let's give it a shot. Yep, all right, so there's one packet. Okay, next up, let's go back to the serial command. Signals is master out, slave in. So if this is the master out, it's not actually sending any data. So why don't we just put that on channel 4? It's just not gonna do anything. Okay, threshold, who cares? MISO, master in, slave out. So if this was the microcontroller, that's the data coming back into it. And that's what we do care about because we want to see what this board is spitting out. All right, so that's channel 2. What if they were wireless oscilloscope cables? Wouldn't that be awesome?
They would work through quantum entanglement.
Oh, you and your quantum entanglement.
Quantum entangled oscilloscope cables.
Actually, that would be pretty awesome.
That's a huge signal.
There it is.
It's off the charts.
Let's just take a look at that. Yep, so that the clock is constant and the data signal is different. Okay, next, we want the chip select. So SPI devices, you could have multiple SPI devices in the same bus, and clock, MISO, MOSI are all on the same lines. But then how you specify what device you want to talk to, each device has its own chip select line. So if chip select is low, which is active low, that device is active, and the rest of the devices go into high impedance mode.
Okay.
So they don't affect the signals on the bus. So let's use channel 3 for that, for chip select. 3, okay, let's hook it up. And that should give us a frame, you know, like a start-stop frame. I mean, granted, you can obviously see a pack of 8 there. I think it's this one right here. All right, let's take a look at one of these. Cool.
Awesome, right?
Yeah, so 1, 2, 3. So that would be 1F in hex because we have it set to MSB, most significant bit first. So now what I guess we should do is actually have it display what's going on. Actually, we should be seeing that at the bottom. Oh wait, threshold probably is wrong. See how it says 2.5 millivolts? That's not very much. There we go. There it locked in, see?
Yeah.
Cool. Let's check the, see how it's framed by low chip select? So I guess we could do chip select high or chip select low. Looks like low is the default. Cool. So there is the bus analysis. Let's just stop it. Oh, we stopped on FD. Wonderful. Okay, Felix, what are your feelings overall of the Keysight Msox3104T?
I'll tell you what, I really like that it has all the controls and the interface between the touchscreen and the controls. It's a very balanced.
The best of both worlds.
Yeah, quite balanced.
Yeah, the display on this and the touch controls on the display are a lot more intuitive than they were on the Rode and Swartz.
And I like having controls for each channel.
Oh yeah, the knobs. It takes out the guesswork, definitely. Yeah, I would say the only thing I don't really like about it is the bezel that I complained about earlier. Overall though, you'd like this one the best so far?
Yep, this thing's awesome.
Cool.
Let's evaluate this MSO58.
This is a very high-end scope that Tektronix sent us for evaluation. It has a lot of features. It's also enormous. So we're going to take a look at this scope and see what it can do that the other scopes cannot. Okay, I have this old Atari 2600 hooked up with the game Frogger. We have it hooked up to a little screen here so we can make sure that it works. It does. Okay, what we're going to do is we're going to look at the crystal oscillator frequency going into the video chip and see what its timing is. And then we can try to replicate it using the arbitrary function generator. All right, ready?
Yeah.
Turn on the Atari. Let's see what signals we can find. There's something. Wow, data. What is that? What's pin 2 on the TIA? Oh, that's part of the video image. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can you zoom in on that?
There's nothing going on here.
Here, let's do AutoSat. There should be something there. There we go. Cool. It's a really crappy square wave. All right, get a frequency measurement of that. Add. Hey, it's the NTSC color burst frequency, which is also written on the data sheet. So now if we look, there's an output on this chip too. There it is. Oh, gross. So disgusting. Let's get the other probe. Look at the difference between them. See, it's divide by 3. Yeah, so this is the pixel clock and that is the CPU clock. Pretty exciting, huh?
Very cool.
So what I think we should do is use the arbitrary function generator to create the pixel clock signal and see if we can get this to run using a signal sent from the scope, kind of to fake it. All right, so why don't you do this? Have you done the AFG setting on this before?
Yeah.
So why don't you get that set up and I will break the traces on the Atari that will allow us to jumper that signal in. Sound like a deal?
Yeah.
Okay, I cut the trace from the oscillator to the graphics chip. So now it shouldn't work. It should do nothing because the video signal doesn't work. So let me see if I can just patch it in to make sure that it will do something if it's actually hooked up. Hey Max, can you flip a switch for me? That leftmost switch there, flip it on when flip it up when I say so. Go. Yep. All right, off. Okay, we definitely cut the right trace. Now I'm going to try to replicate that signal using the arbitrary function generator on the oscilloscope. All right, let's generate some frequencies. I'm going to hit arbitrary function generator. Let's see, square. That should work. I mean, we can do sine wave, pulse, noise, all sorts of stuff, but square is what we want. Hey, we can make a better square wave than what was there originally. Frequency, I don't know, the frequency has to be exact. Oh, that's interesting. You can change the period or the frequency. All right, let's see if 3.579, blah, 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 blah. As long as we're in the ballpark, we should be good. All right, 3.579575. We don't get that many decimal places with this, but that should be enough. So let's just check it. I'm gonna hook the probe up to the arbitrary function generator, but a sloth ain't one. Why am I not getting anything from this? High level, 10 millivolts. That's not very much. Oh yeah, for some reason the high level was set super low. There it is. All right, let's do 5 volts. Cool. Low level 0 volts. Nice. All right. There is our new waveform. I mean, I guess we could try to make it look crappy like the one that was on the Atari, but I would think this would work. All right, let's do this. Let's disconnect this. Wonder if that works without the ground. Yeah. Oh, well, it does, but it's really gross. Okay, so I'm gonna attach this to the Atari's ground. The Atari's like, what are you doing to me? I will give you a new body and new troops to command. Zoop. It works! Battletoads dance. Cool, so what we did there was we used the scope, we looked at the frequency coming off of the Atari's ancient oscillator, which is basically just a crystal and a transistor. Then we cut that trace and we replicated the signal using the arbitrary frequency generator on the MSO58 scope, and then we fed that directly into the chip that requires that timing signal, and it worked. It allows the NTSC signal to be generated, giving us a picture. And then, well, that's a different issue, so we'll have to figure that issue out later. Curious if the signal going out to the CPU is cleaner now too. Yeah, so that results in a cleaner signal being generated by the video chip going back to the CPU as well. Great. So Felix, what are your feelings on the Tektronix MSO58?
I think this is a lot of oscilloscope. It's very amazing, definitely professional grade.
Yeah, it's kind of even beyond what we really need here at the shop. Although it's been a lot of fun to play with. That's kind of obvious, but I like how big the screen is, and there's tons of real estate. You can move everything around, and you know, the kind of information that gets bunched up on my other Tektronix screen, I mean, there's plenty of room to read it. It does seem like it relies on the touchscreen a bit much. I know you can turn off the touchscreen controls, but I think you'd pretty much have to use a keyboard or mouse in lieu of it. Yeah, so obviously the scope has a lot of channels, a lot of I/O. It's very fast. It has a very large memory for the samples. So yeah, it's pretty beefy. So negatives, you know, if we had to bring them up, it's got a full computer inside of it, so it boots slower than the other scopes.
Not very portable.
So you like all the video outputs this has?
Yeah.
It's handy for us because a lot of times we're capturing the scope action. We don't want to film the screen. We prefer there to be video. So yeah, that was pretty handy because the old one just has VGA, but this has DisplayPort, DVI, and VGA, which is pretty cool.
Quite amazing.
Well, that's all we have for today, but we hope you enjoyed our overview of multiple different types of oscilloscopes from multiple different manufacturers.
Have you used an oscilloscope? Are you interested in learning more about oscilloscopes? Or are you in the market to buy an oscilloscope? If so, please visit us online at element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll scope you next time. Hello and welcome back to the Ben Heck Show.
Ben, why are you so happy?
I'm just trying to make Max laugh now. Hello and welcome back to the Ben Heck Show.
Ben, why are you so happy and excited?
Hello and welcome back to the Ben Heck Show.
Ben, why are you so happy?
Well, do you know that William Taft tried to have a Billy Possum?
I heard about that.
Because he loved possums. So he made like a stuffed possum. He was gonna use that because he's like, I can be like Teddy Roosevelt. Guys, why are you fighting over this hex game? Can you just stop playing it, or do you love it that much? Share it.
Well, I don't want to share.
What if we made another one, or figured out a way to make it a kit even?
That'd be brilliant. Then we wouldn't have to fight.
It was super duper ultra mega time.
Like Steve Jobs once said, difficult is easy, simple is hard.